So let's say you're seated peacefully in the exam, minding your own business, and they decide to ask you a situation like this one. It says a box with a mass of 45 kg is pulled with a force of 90 newtons at an angle of 50 degrees to the horizontal. The box moves at a constant velocity. So every time you hear the phrase constant velocity, you must know that the net force acting on this block is 0. And also that the acceleration of this block is 0. So before we can do anything, I want us to draw a free body diagram showing all the forces acting on this block. So we know that the block is represented as a dot and the forces as arrows pointing away from the dot. So this is what we have. So because this block is on a horizontal surface, there's going to be a normal force, which is perpendicular to the surface. And we are also going to have an applied force, which is going in this direction at an angle of cos. So we call this F applied. Now, every time you have a force which is acting at an angle, you must know that the gravitational force will be longer or greater than the normal force. This is the pulling situation. But if a force was applied, let's say a person was pushing this block, then the normal force will be greater than the gravitational force. But you don't need to stress. We'll do that situation as well. Now the question is, why is the gravitational force greater than the normal force? It's because the applied force has a vertical component. So if we take the normal force and add it to the vertical component of the applied force, we get the gravitational force. That is the reason why. And one thing you must know is that on your free body diagram, you are not supposed to show the components of the force, because by definition, the free body diagram shows the forces acting on your object, not the components of the forces. Very important. And then we also have another force, which is the kinetic frictional force. And this one, it opposes the motion of an object, meaning it always acts in the opposite direction. So this is your nice free body diagram. Then we can worry about what the questions are saying. Of course, if they don't ask you to draw the free body diagram, you need to draw it aside on your rough work section. So the first question says, define the term kinetic frictional force. That's how we knew that we have frictional force in this case, because in the statement, there was no mentioning of the frictional force. Do you see that? You need to be observant. So we are not going to define the kinetic frictional force. We trust you, you can do that. Then the next one says, state Newton's first law of motion in weights. We are also not going to do that. We entrust you to take care of it. Now let's look at 3.3. It says, calculate the magnitude of the horizontal component of the applied force. In other words, F in the X. Because we know that any two-dimensional vector or any vector which is acting at an angle has two components. So let's go ahead and calculate the magnitude of the horizontal component of this applied force. So we know that this is the formula we use in order to resolve the applied force. Now we say the magnitude of the force itself is 90 newtons. And then we times this by the cosine of 50 degrees. So if you go to your calculator and say 90 cos 50 degrees, you simply get 57.85 newtons. So this is the magnitude of the horizontal component of the applied force. Right. Let's look at the next question. And guys, remember, these formulae for resolving forces are not given to you in the exam. So they have to be in your head. You must memorize them. Right. So 3.4 says, calculate the magnitude of the normal force. So in order for us to calculate the magnitude of the normal force, we need to separate our forces. In other words, we need to focus on the vertical forces because the normal force is a vertical force. So if we look at the vertical forces, we have the normal force, which is going upwards. And then we have the gravitational force, which is larger than the normal force. But we also have a vertical component of the applied force. Do you see that? Right. So in this case, because a force is pulling this grade upwards at an angle, you must know that if you take your normal force, you add it to the vertical component of the applied force, this is going to give you the gravitational force. Because we don't really have a formula for the normal force. It depends on the situation we are given or we are dealing with. So in this case, this is how we calculate the normal force. So if we make the normal force the subject of the formula, it's just going to be the gravitational force minus the vertical component of the applied force. So how do we calculate the gravitational force? We take the mass of an object, we multiply it by the acceleration due to gravity. But how do we calculate the vertical component of a force? Well, we take the force itself, we multiply it by the sine of the angle. So the mass of this block is 45 kg. Acceleration due to gravity is a constant. The magnitude of the force is 90 newtons. And then we say sine 50 degrees. Then from this point, we go to our calculator and press everything. So we find that the magnitude of the normal force will just be 372.06 newtons to 2 decimal places. Do you see that? Right. Then let's look at the next question. So 3.5 says, calculate the coefficient of kinetic friction. Do you see that? But now, in order for us to calculate the coefficient of kinetic friction, firstly, we need to know what is the magnitude of the normal force. Sorry, the frictional force. Sorry about that. Because we already know the magnitude of the normal force. Do you see that? So that's what we need to do. Why do we need to calculate the magnitude of the frictional force? It's because this is how we define the kinetic frictional force. We take the coefficient of kinetic friction, we multiply it by the normal force. So the normal force, we already have it. We just need to find the kinetic frictional force. So now we see we are dealing with horizontal forces. So if we look at horizontal motion, we know that we have the horizontal component of the applied force, which is going to the right. And then we have the kinetic frictional force, which is going to the left. Remember what they told us in the statement? They said this block is moving at a constant velocity. So if we look at these forces, we only have two forces which are going in the opposite direction. So we can safely say they are equal in magnitude. Do you see that? Yes. So we can safely say the kinetic frictional force is equal to the horizontal component of the applied force. Because in order for the net force to be 0, the forces must be equal in magnitude, but they must be opposite in direction. So this means the magnitude of the kinetic frictional force will just be 57.85 newtons. So this is what we have. So now that we know the magnitude of the kinetic frictional force, we go to the definition of the kinetic frictional force. So we take the coefficient of kinetic friction and then we multiply it by the normal force. So the magnitude of the frictional force is this much. We are looking for the coefficient of kinetic friction, but the normal force will be 372.06. Then from this point, in order for us to solve for the coefficient, we need to divide both sides by 372.06. So if you go to your calculator and say 57.85 divided by 372.06, you find that the coefficient of kinetic friction will simply be 0.16, like that. And what is the unit for the coefficient of kinetic friction? It is unitless. Why? Because it's a ratio of the kinetic frictional force to the normal force. Think of it. You say the coefficient of kinetic friction is equal to the kinetic frictional force divided by the normal force. The frictional force is measured in newtons. The normal force is measured in newtons. So Newton and Newton will commit suicide. So it doesn't have a unit. Are you fine? Yes. Now let's look at the last question. So the last question says, will the coefficient of kinetic friction change if the angle of the applied force is decreased? Write only yes or no and give a reason for your answer. So here you'll simply tell them no, it's not going to change. Why? It's because the coefficient of kinetic friction, it depends only on the type of materials that are in contact. In other words, the type of material that the ground is composed of, as well as the block is composed of. So if these materials are smooth, the coefficient of kinetic friction will be small. But if these materials are rough, then the coefficient will be large. So it only depends on the type of material that the surfaces are composed of. Over and out.